So in section 2.2, we're going to continue looking at new types of equations. So this unit's all about solving equations. We want to look at rational equations. And maybe you remember from the first chapter, rational referred to fractions. So basically all our equations are going to have some sort of fractions. So they won't necessarily just have numbers in their denominators, but sometimes they'll have variables. Usually they're going to have the variables as well in the denominators. Now we want to warm up with solving some equations with some fractions. That'll turn out to be basic equations. Let's see. All right, here we go. We'll just say exercises. Solve the equation. Those are instructions. Solve the equation. All right, so I'll start with the number 1. We have x minus 2 over 7. So we have a fraction plus x plus 4 over 8 equals 57 over 56. So, and section 2.1, we actually had some equations, some basic equations with fractions. This is actually a basic equation, but it has fractions. It's kind of a, I guess this is like a problem that would occur in 2.1. So we're doing a little refresh here. So how do we deal with fractions? How do we deal with fractions when we have an equation? Well, you want to get rid of your fractions by first you want to find an LCD, and then you want to multiply through by the LCD. So our first task here is to find an LCD. That's what we're going to be doing, finding an LCD. Notice we have 3 denominators, 7, 8, and 56. So I'm going to call this first one the red denominator. Denominator 1 is 7. Now we know 7 is a prime number, so we don't need to factor that. Then we go on to the next denominator, 8 right here. Eight is not prime. If you think about 8 breaks down into 2 times 2 times 2, right? 2 times 2 times 2, where the 2's are primes. In other words, 2 to the 3rd power, right? 2 to the 3rd power. And the third denominator here is 56. We know 8 times 7 is 56, right? Now 7 is a prime, but 8 is not prime. 8 can be written as 2 to the 3rd power, right? 2 times 2 times 2 gives you 8. So you got 2 to the 3rd power times 7. Yeah, so 2 is a prime, and 7 is a prime. So you have 2 to the 3rd power times 7. So that's how you write 56 as a prime power factorization. Now remember, when we're finding the LCD, you have to take every single prime that shows up among your denominators and you take the largest power. So notice, first of all, a 2 shows up here and here. We're going to take the largest of those powers. We're going to take the cube power. So 2 to the 3rd power. Then also 7 shows up. It shows up here and it also shows up here. So we have to include 7. So 2 to the 3rd times 7. In other words, 8 times 7. In other words, 56. 56 is our LCD. So what we're going to do, we're going to multiply both sides of the equation by the LCD. Multiply both sides of the equation by the LCD. So what that amounts to doing, that amounts to sticking a 56 in front of the first fraction, x minus 2 over 7. And then plus, we're going to stick a 56 in front of the second fraction. Call it the blue fraction. So we've multiplied through the left side by 56. And then on the right side, you're going to have to multiply that by 56. What you do to one side, you have to do to the other side. So I'm going to take a kind of a purplish 56, or maybe it's a pinkish 56, and multiply through on the left side. 57 over 56. Sorry, the right side, that's the right side. Now, if you're not comfortable with multiplying a whole number by a fraction, you can write this as 56 over 1. All right, so what I have here, I have 56. And we can multiply the 1 times the 7 on bottom and get a 7 there. Multiplying 1 times 7. And I'm going to keep x minus 2 in parentheses. And then plus. I'm going to leave the 56 up top. And I'm going to put a fraction bar. And on the bottom, I'm going to do 1 times the blue 8. It's going to give me 8. And then I'm going to put my blue parentheses and x plus 4 in there. And then what can happen here, we can actually cancel these 56s. And cancel out the 56s directly. And that just leaves us with 57 on top over 1, which is 57, right? That's just 57 over 1, which is 57. Now, we want to simplify the purplish, pinkish fractions. 56 divided by 7. What is 56 divided by 7? 56 divided by 7 is 8. So we have a pink 8 and a red x minus 2. All right, then we have a plus. Then we have 56 over 8. 56 divided by 8 is 7. So I'm going to write a pink 7 or a purple 7, whatever color that is. And then a blue x plus 4. And then we got a green equal sign and then a green 57. Okay, so what have we done basically? We got rid of all the fractions, right? We found the LCD, we multiplied both sides through by the LCD, and we did some reductions, which eliminated our fractions. So now this is a simple matter of cleaning up the left side. What do we mean clean up the left side? We want to distribute the 8, so 8 times x, 8x, 8 times negative 2 is negative 16. We're going to distribute through a positive 7. 7 times x is 7x. That's plus 7x because it's a positive 7x. And 7 times 4 is going to be positive 28. And on the right-hand side, well, we're going to have an equal sign first and then a 57. Now, I got to combine my like terms. Combine my like terms. I have here 8x and 7x. If someone gave me 8 x's and then 7 more x's, I have a total of 15, right? 15 x's. And then I have, what, minus 16 and plus 28. What's negative 16 plus 28 is plus 12. And all that's equal to 57. So we've cleaned up the left-hand side. Now we just want to get the x by itself. So we're going to subtract a 12 from each side to get rid of that plus 12 there. It's going to give us 15x by itself on the left. 12 and negative 12 cancel. We're going to have an equal sign. 57 minus 12. What's 57 minus 12? It's 45, right? And then we would divide both sides by 15. To get rid of that multiplication by 15 on the x. So we're going to cancel out the 15s, and we're going to have just an x by itself on the left. And on the right, we're going to have 45 divided by 15. 45 divided by 15 is 3. So your solution here is x equals 3. All right, let's move on. All right, so let's do so that was just a bit of a review for equations like we had done in our last section. So we actually want to start doing equations with fractions, but the denominators just don't have numbers. So I mean, if you look at this problem, look at the denominators. They were 7, 8, and 56, right? They were just numbers. But we want to do some equations where the denominators are not just having numbers, but they have variables. So you have an algebraic expression on top, maybe an algebraic expression on the bottom. Right, so this is going to be a number 2. We're going to have 7x plus 2 on top. And on bottom, x minus 8. And then minus 5, and then equals 10 on top of a fraction, and on bottom, x minus 8. So, first of all, you notice you have fractions, and you say, hey, I don't like fractions, so I want to get rid of them, so I got to find an LCD. Now, if you notice here, there's only one denominator showing up, right? There's only one denominator showing up. That's x minus 8. It shows up in 2 places, but only one denominator shows up. So that's going to be your LCD. It's the only denominator that shows up. So x minus 8, easy to find there. Okay, so we're going to take the LCD, x minus 8, and do the same strategy we did before. Multiply through both sides by x minus 8. We're going to multiply through the left side, multiply to the right side. What you do to one side, you do to the other side. So you have x minus 8. Actually, I'm going to put it, rather than putting it in front, I'm going to put it behind each term. So I'm going to say this first term here is my blue term here. I'm going to take 7x plus 2 over x minus 8. And I'm going to multiply that by a pink x minus 8, or whatever color it is. Okay, then I got a minus 5, and then I got to multiply that by it. X minus 8. Pink, purple, x minus 8. So I multiplied the left side by x minus 8. Now I'm going to put an equal sign. I'm going to have 10 over x minus 8, and I got to multiply that green all by the pink, purple, x minus 8. Okay, so I multiplied the left side by x minus 8. I multiplied the right side by x minus 8. Now remember, if you're not comfortable with multiplying x minus 8 by those fractions, you can always put a 1 on bottom. I'm going to put a 1 on bottom because some people get a little confused. So x minus 8 is on top in pink, and x minus 8 is on bottom in blue, so we can cancel those. The same thing goes when you're dealing with x minus 8 in pink on the right-hand side and x minus 8 in green on the right-hand side. These are going to cancel. So essentially what you get on the left side, you get 7x plus 2 in blue over 1, which is 7x plus 2. Right, anything over 1 is itself, so 7x plus 2 over 1 is 7x plus 2. And we're going to have minus 5, parentheses, x minus 8. And then we're going to have an equal sign, and then we're going to have 10 over 1, 10 over a pink one. That's 10 over 1 is 10, right? So what we've done, we've gotten rid of the fractions, right? We've reduced this to a basic equation where we don't have any variable expressions down in the denominators. So we just need to clean up the left side now. We need to clean up the left side. So I'm going to keep the 7x plus 2 for now. And I want to take this minus 5 right here. You see this minus 5, and I want to distribute that. So you got to take the whole thing. You got to think about this whole thing as a minus 5, not just a 5, but a minus 5. So negative 5 times x is going to give me negative 5x. And negative 5 times negative 8 is positive 40. And that's all going to be equal to 10. So I distributed negative 5 through, and now I want to combine my like terms. Okay, what do I want to combine? I want to combine here. What color should I use? Use a different color. I'll use a different color. I want to combine the x's, so 7x with negative 5x. 7x minus 5x is 2x. And then I'll combine 2 and 40. 2 and 40. Positive 2 and positive 40 is going to give me positive 42. And that's going to be all equal to 10. Just coming along nicely. So we got 2x on the left side. We have the x's on the left side. We want to get rid of that positive 42 on the left. We want to get it to the right. So we'll just subtract the 42 from each side. I don't know how that changed on me. It's very strange. All right, so it's supposed to be yellow minus 42. So on the left side, we're going to have 2x. 42 and negative 42 cancel. We're going to have an equal sign. And then 10 minus 42. 10 minus 42 is going to give me minus 32. And then from there, I'll just divide both sides by 2 to eliminate that 2 that's connected to the x. And of course, the 2's cancel. And we're going to have an orange x equals, what's negative 32 divided by 2? Negative 32 divided by 2 would be a negative 16. Now, right now, this is just a potential solution. You have to be careful. Anytime you have a variable in the denominator, you have to make sure that your potential solution does not violate that denominator. So for example, if I got x equals 8 for my potential solution here, I would not be able to plug that into the denominator, right? If I plugged 8 here into the denominator, I'd have 8 minus 8, which is 0, and you can't have 0 in a denominator. Remember, you cannot have 0 in a denominator. Not allowed to have 0 in the denominator because you can't divide by 0 in that. So if I were to get x equals 8 for my potential solution, I would have to say, sorry, I can't keep that solution, and that would be no real solution in that case. But we have we didn't get 8 for a potential solution, so we're in good shape. Meaning we can keep this solution here of 16. 16 is going to actually work. It's not going to violate the denominator at all. So yes, that's our solution. Negative 16 is a correct solution. All right. So just be aware that when you have variables in the denominator, you got to make sure that when you plug in your potential solution, it doesn't make the denominator 0. You don't want a 0 denominator ever, because you can't divide by 0. All right, so there we go. There's another example. Is that 2? Let me see for a second. Okay. Number 3. Make sure I get my numbers right. Number 3. What do we have on number 3? I'm looking here. Okay, I got 3 on top and on bottom, x minus 6. And then I have plus 2 on top, and then on bottom, x minus 4. And then I have, this is equal to 5 over x minus 4. So again, we got fractions, and our denominator's got variables, so this is called a rational equation. So anytime this situation shows up, anytime we get fractions in an equation, you want to get rid of your fractions. How do you do it? You find an LCD and then multiply through by the LCD on both sides. So my first denominator is x minus 6. Now, does that factor? No, right? That's already prime. You can't factor x minus 6. Second denominator, x minus 4. Can you factor that any further? No, it's already prime. Third denominator. Well, the third denominator turns out to be the same as the first denominator. It's x minus 4. The second denominator, sorry. It's the same as the second denominator. That's already prime. So when you're finding your LCD, remember you have to include every single prime that shows up, every distinct prime that shows up, and take the largest power if it's a common prime. So first of all, we see x minus 4 shows up. It not only shows up in the third denominator, but also second denominator. So we have to include that. And how many times does it show up maximum? Well, it shows up one time here, so a maximum of one time for each of those denominators. So x minus 4 is our prime there from denominators 2 and 3. All right, so also we have to include x minus 6. That's another prime that shows up. So we include that and we multiply these together. So x minus 4, x minus 6 is our LCD. All right, so what we're going to do, we're going to multiply both sides of the equation through by the LCD. So I'm going to take the blue term first, 3 over x minus 6, put parentheses around. Now I'm going to multiply it by that purple LCD. Now it's like really looking violet or purple, not as pink anymore. X minus 4, x minus 6. Okay, right, please. Thank you. All right, then we got a plus 2 over x minus 4. I'm going to put a parenthesis around that, and I'm going to multiply through by a purple x minus 4, x minus 6. Okay, then I'm going to have a green equal sign. It looks like I'm going to have to clear out some of this scratch work here on the side. Sorry about that. There's not enough space on this iPad. And then we're going to have our green, in parentheses, 5 over x minus 4. And we're going to multiply through by the purple LCD, x minus 4, x minus 6. Okay, so all we've done, we've multiplied through by the LCD, x minus 4, x minus 6, x minus 4, x minus 6, x minus 4, x minus 6. And if you're uncomfortable with multiplying those algebraic expressions by those fractions, we can put a 1 on bottom. And what's going to happen here is, in the first situation where you have the blue multiplied by the purple, x minus 6 on top is going to cancel with x minus 6 at the bottom. In the case where the red and the purple are together, we're going to have x minus 4 on top, canceling with x minus 4 on bottom. And in the green and purple situation, we're going to have x minus 4 on top, canceling with x minus 4 on bottom. So what's left then? We're going to have what? 3 parentheses x minus 4. That's over 1. You don't really need to write the 1 on bottom. And then plus, in red, 2, what's left? X minus 6. And then on bottom you have 1, but you don't need to write that. And you have that's equal to 5, and then parentheses, x minus 6. That's over 1, you don't need to write that. So we've gotten rid of all our fractions, We're just going to clean up the left side, clean up the right side. So I'm going to distribute my 3 here. 3 times x is 3x. 3 times negative 4 is negative 12. Then I'm going to distribute my 2. 2 times x is 2x. 2 times negative 6 is negative 12. Then we're going to distribute the 5. 5 times x is 5x. 5 times negative 6 is negative 30. All right, and we're going to combine like terms now, right? Combine like terms. What color should I use to combine? I'll use that orange again. 3x and 2x. You combine those on the left side. That's going to give us 5x. Negative 12 and negative 12 is going to give you a negative 24. All right. And then on the right-hand side, we're going to have 5x minus 30. 5x minus 30, all right. So then what we want to do, I don't know, let's say we wanted to get all the variables to the left-hand side. What we could do, we could subtract a 5x from the right side. So subtract 5x from the left side, and you end up with 5x and minus 5x cancel. You get negative 24 equals 5x and negative 5x cancel equals negative 30. Wait a second, that's a contradiction, right? Is a contradiction. It's not true. So if you get a contradiction, what does that mean? That means this equation has no solution. Okay, that can happen sometimes. There's no solution to this equation. So that'll happen occasionally. All right, I think we're going to stop right there in this video, and we're going to pick up. We'll pick up in the next video. Yeah, we'll pick up in the next video. A few more examples of this type of thing.